Hello, everyone. Thank you for joining us for the restart of Safer Sim individual project webinars. I am Dawn Marshall. I'm the director of the Safer Sim University Transportation Center, and I am so glad you're here. For the past 2 years, we've been doing online symposia and then in-person symposia, and we are now going back to individual projects. So I hope you enjoy this one. I'm going to briefly introduce Dr. Emily Shull from the University of Iowa and hand the floor to her so she can get started telling you about her work.
Cool. Thank you, Dawn. Just a heads up, my Wi-Fi has been a little funny today, so I'm just going to turn my video off for the duration of my presentation just to make sure everything goes smoothly. So today I'm going to talk about a study that I did. It's kind of a theory rooted in psychology known as the gap effect, and how it could potentially play a role in the— Here's what I found. Oops, not Siri. Sorry. How it could potentially play a role in the transition of control when using conditionally automated driving. Before I start, I want to give a few thanks to some very important people in this study. First of all, Dr. John Gaspar, who has been my research advisor roughly for the past 5 years throughout my PhD studies. And he really gave me a lot of support and guidance throughout a lot of this Safer Sim work. Dr. Daniel McGehee, my primary advisor throughout my PhD studies. Dawn Marshall, of course, for all of your support and management of Safer Sim. And Andy Veit for helping me to restore an old mini sim in our lab on campus that we were able to use for data collection. So, like I mentioned in the on the title slide, this study really revolves around conditional automation, and I'm sure a lot of you are pretty familiar with conditional automation, or at least the 5 levels of automation. So I'm just going to give a brief overview of level 3 conditional automation. So the automation is able to control both the lateral and longitudinal position of the vehicle, and it's also equipped with object and event detection and response, meaning that it's able to monitor the environment. And then when it detects that it's going to exit the operational design domain or it's reaching its limitations, it will issue a request to intervene so that the operator knows that they need to then take back control of the driving task. So because it can do this, the operator is then allowed to disengage from the driving task and engage in other tasks. And really the issue comes up when we talk about how we can help the driver to shift their attention from whatever distraction task they're involved in back to the driving task when needed. So it's likely that operators of conditionally automated vehicles are going to be involved in these distracting tasks, and they're likely going to be pretty visually demanding. For example, being on your phone or playing a game on the infotainment center. And this makes it much more difficult for the operator to then shift back to the driving task. So one thing we can do is to help the driver to understand their expectations, as well as understand the system's expectations. So for example, the automated system is expected to issue a request to intervene so that the operator has sufficient time to take back control. And then at the same time, the operator is expected to remain receptive to this trend, to the request to intervene. So my goal here really was to understand how we can best support the operator to allocate their attention where it's needed, when it needs to be there. So in other words, when the automated system issues a request to intervene, we want the operator to turn their attention from the distracting task back to the forward roadway so they can begin regaining situation awareness and preparing for a possible takeover. One way I looked at for potentially helping the operator to shift their attention is through the gap effect, which, like I said at the beginning, is a theory based in psychology that facilitates the shift of attention from one location to another. But to keep things pretty high level today, I'm going to talk about the gap effect in terms of the stickiness of attention. So I initially ran my first SaferSim study using the gap effect. And this current study is kind of based on a couple things I found from that first study. So I'm going to kind of explain my method of implementing the gap effect using my previous study. So the non-driving task that I used was a trivia game, which was located on a tablet to the right of the steering wheel. And during the drive, participants were incentivized to play the trivia game. And when a request to intervene appeared, the goal was for the participant to then turn their attention away from the trivia task to the forward roadway and eventually take back control of the vehicle. So there were two different kinds of events: overlap events and gap events. So for the overlap events, the trivia screen remained on for the duration of the event. Whereas for the gap events, the trivia screen turned off 300 milliseconds before the request to intervene. So to kind of describe this in terms of the stickiness of attention, for the overlap events, attention will remain stuck to the trivia screen until you unstick it and shift it to the roadway. Whereas for the gap events, attention is unstuck from the trivia screen when it turns off. Thereby, if in line with previous research, it should be able to move faster to the next point, which would be the forward roadway. And in that first study, we did find faster responses with the 300 millisecond gap compared to the overlap events. So in summary, in a way, we're kind of priming the driver to shift their attention before they actually need to. But instead of adding another stimulus here, we're simply removing the distractor. The study I'm going to cover here today is, like I said, an extension of a previous SaferSim study. So I'm going to briefly describe the motivation for these new research questions as I go through the experimental designs. So this question, the first one, we're investigating whether we can include more gap intervals to determine whether shorter or longer gap intervals are more effective to unstick attention. So here, as you see, in addition to the overlap condition and the 300 millisecond gap condition, we also included 150 milliseconds and 450 millisecond gap conditions. So when I'm talking about events, I know it's been kind of vague. This is the kind of takeover events that participants saw throughout the drive. So it kind of mimicked a failure of the lane centering sensor and began drifting towards the right-hand shoulder once it lost detection of that lane line. And then at a certain point, the automated system issues a request to intervene, at which point the participant was expected to take over. So I'll play this video here. I'm not sure the sound is, I'll try it with the sound, but it might be kind of loud. So here the vehicle is just drifting over towards that lane. And then once the request to intervene is given, the participant was expected to take over. And like I said, there were two different kinds of events, the overlap and gap events. So this video is an example of an overlap event where the trivia screen remains on. So this clip is a bit shortened. It's already most of the way through the event, but it just kind of shows that once the request to intervene appears, that trivia screen is still up. And then just for reference, this is the audio cue that also played with the request to intervene. And that event was compared to the gap event. So this is an example of the 300 millisecond gap event. And this one you have to look a bit closer, but you'll notice that the trivia screen turns off just before the request to intervene icon appears. And so for this one, there was, like I said, the 150 millisecond, 300 millisecond, and 450 millisecond gap events. Oops. And then moving on to the second research question, here I aimed to evaluate whether we could add feedback in place of the gap to facilitate the transition of control. So in response to some confusion that we saw in the first study a few years back, when the trivia screen turned off, we saw or found that a lot of participants were either expressing confusion to the research assistant or kind of remaining engaged with the trivia task because they were confused or frustrated why it was turning off. So this alternative was kind of our way of alleviating that that confusion. So for the we had two drives. There was a no feedback drive and a feedback drive. So for the first drive, let's say the no feedback drive, we of course still had the overlap events where the trivia screen remained on. And then for the gap events, the trivia screen turned off at the predetermined gap interval. And then that was compared with the what we called the feedback drive. And here we introduced kind of a priming stimulus in place of the trivia screen blinking by kind of showing the participant a warning indicating that the automation could not detect the lane line. And this was our way of kind of giving them more context as to why the screen was turning off. And here we hypothesized that we would see faster lookup times because there might be less dwelling on the trivia screen turning off. So moving on to the actual study design, we recruited 48 participants ages 25 to 40, and they drove our NADS mini-sim fixed-base driving simulator, which was located at the Applied Cognitive Engineering Lab in our College of Engineering. The mini-sim was equipped with what we called auto drive, which, like I said, was a level 3 conditional automation operating at 65 miles per hour. And throughout the 35-minute drives, we incentivized participants to engage in the trivia game. And we did this because most operators, when using conditional automation, are likely to be engaged in something. And so this was our kind of our way of controlling for that, ensuring that they would be engaged in it. So we told participants that if they could answer, I think, 250 trivia questions correctly, they would earn an extra $20 on top of their compensation. But really everyone received that extra 20. And then, like I said, there were two different study drives. There was the no feedback drive and the feedback drive, and both kind of followed this same route from start to finish, about 35 minutes each. And then we gave the participant 10 minutes between each drive to kind of let them take a break. And then throughout each drive, there were 8 takeover events, which were just like the ones you saw earlier, and randomized between the different gap conditions. So for this, I really focused on 2 main dependent variables as a measure of the success of the transition of control. So for the first one, I measured the lookup time, which I did by manually video coding the 10 seconds before through 10 seconds after each request to intervene. And the lookup time was measured as the first glance at the forward roadway after the request to intervene was issued. And then the takeover time was measured as the time to disengage or turn off the auto drive after receiving the request to intervene. So moving on to the results, there's a lot to look at here, so I'm going to kind of explain everything that we're seeing before I get into it. So the overall distribution is shown for each condition. Here it's the distribution of lookup times. And then the individual points you see are representing the lookup times for each event. And the upper half of each plot shows the density of lookup times, and the lower half shows the interquartile range and the median. And then the red dot in each distribution indicates the mean lookup time for each condition, and that's also noted with the standard deviation to the right of each plot. And then finally, the request to intervene time is shown at 0 seconds on the x-axis. So for the sake of these analyses, I removed all of the early lookup and takeover times, and early being before the request to intervene. So looking at the feedback conditions first, the no feedback compared to feedback, we did not really see any significant difference between the lookup times between these two. Both of them had about equal distributions, medians, and means. But then compared with the overlap condition, we saw that both feedback and the no feedback drives had significantly faster lookup times, which indicates that the gap is effectively disengaging their visual attention faster compared to the overlap. And then in terms of the takeover time, the time to disengage the auto drive, here we did not see any significant differences between the overlap, feedback, and no feedback conditions. They were all relatively similar in timing. And now moving on to the gap condition with the different gap intervals versus the overlap. We found a significant difference between the conditions, specifically with the 450 millisecond gap eliciting faster lookup times compared to the 150 millisecond gap and the overlap conditions. And then finally, in terms of takeover time, we saw similar effects to the lookup time, specifically with the advantage of the 450 millisecond gap compared to the 150 millisecond and the overlap conditions. So for both lookup times and takeover times, we found that the gaps were effective in essentially unsticking attention and facilitating a takeover, especially with the 450 millisecond gap. But we did not see any significant differences between the feedback and the no feedback conditions like we hypothesized. There were, of course, some limitations to this. The repetition of events could have played a kind of an influencing role in the takeover strategies participants had. We did have some participants mention that they began anticipating the takeover events, which is not that surprising given that during the study they were encountering these events 16 times in total. However, for the kind of small difference that we were looking for, I think this kind of simple event was sufficient in kind of measuring that. But again, there was a lack of criticality or urgency associated with this event. So participants might not have felt the need to respond as quickly as they could or should. And then we can't necessarily generalize these effects that we're seeing to all situations where we might see conditional automation operating in. It's hard to say how these effects might be seen in different situations like traffic jams or anything other than kind of a standard straight or curved highway. And then in addition to that, we don't really know how people develop expectations with technologies, and there could have been a chance that we could have reduced confusion if participants were trained on the gap, and it would have been interesting to kind of see how this could have changed their takeover strategies in a way. So bringing it back out to full picture, what does all of this mean really for conditional automation in the real world? So first, I think looking at the theoretical implications, the gap paradigm does seem to be effective in facilitating the shift of gaze away from the non-driving task, which I think is important, as opposed to kind of adding more and more alerts to attract the operator's attention. It could prove to be more effective to simply remove the distractor task from the situation. I think whether abiding by the gap paradigm or not, I think it's very important that we do try to remove that distractor task as best we can, because that's kind of going to be the best way of encouraging the operator to actually turn their attention and priorities back to the driving task. And then finally, concluding this, really the goal of this research was to help the driver to allocate their attention away from the non-driving related task. Specifically, we found that the non-driving related task can, if we remove that, we can unstick attention, which is in line with previous research on the gap effect. And I think for future work, it would be interesting to look at whether the gap conditions can kind of be learned over time, because for the overlap condition, we don't really need to worry about that being learned because they're simply responding to the request to intervene. Whereas I think the gap can be learned and potentially improved upon with experience. So I think future work could look at maybe a between subjects design to kind of evaluate whether the gap could even be more effective once that becomes learned over time. And with that, that's the end of my presentation. If we have time, I can take some questions or comments. And I also left my email here if anyone wants to reach out afterwards.
Thank you very, very much, Emily. Any participants are welcome to unmute and ask questions, or if you are in a noisy background, please feel free to type them in the chat and I'll read them out loud. Emily, can you see the chat?
Yes, I can.
Okay, just making sure.
Thank you, Bill.
Well, hearing no questions, I'll thank Emily once again for a fantastic presentation. You've always done a great job for us, and congratulations on graduating with your PhD. That's super special. At Saferson, we really like to see people come away with those degrees. I don't have anything else. Except that our next webinar is next week, same time, 4:30 Eastern, 3:30 Central. And you should have received a registration link in your email. And everyone who registered for this webinar will receive an email when we have it posted on the YouTube channel, so you can go back and look at it again if you'd like. So thank you very much, everyone.
Yep. Thank you everyone for tuning in, and thanks, Dawn.
My pleasure.